Okay, so now we're going to do density concept questions 1. We've done density concept questions 1, so we're going to do density concept questions 2. So number 1 says, suppose each of the object's 3 dimensions is increased by a factor of 2. So we've made it 2 times wider, 2 times taller, 2 times longer. What happens to the density? And the answer here is no, the density won't change. Density is a material property, so it is not affected by using more or less of the material. So, number 2, we ask, this is the restatement of question number 1. So number 2 is, it is a density property of matter. So 1 and 2, basically this answers both of those simultaneously. Okay, now suppose each of the object's 3 dimensions is increased by a factor of 2 without changing the mass. So now we keep the mass, but we make the object twice as wide, twice as tall, and twice as long. Now, your density will go down by a factor of 8. Because if you want to think of it like this, density is mass per volume, and what we've done is we take the same mass we had a minute ago, but we do 2 lengths and 2 widths and 2 heights. So now I have an 8 in the denominator that I did not have before. So in this case, the object's overall density will change and it will decrease. This is because we have the same amount of particles, the same amount, not about, amount of mass, but 8 times as much volume. Eight times the volume. So much smaller density ratio. We made the denominator get larger, therefore the numerator has to get, if the numerator stays the same and the denominator gets bigger, the overall fraction goes down. Okay, so now, number 4. A stonecutter cuts off a section of a marble slab that is 1/8 the weight of the original slab. How does the density of the cut section compare to the density of the original? The cut section has the exact same density because although it has less mass, it also is smaller, so it occupies less volume. So proportionally, the change stays the same. If you cut 1/8 of the weight off, you get 1/8 of the volume off as well, which means you get the same density. Number 5, a cylinder contains 2 grams of oxygen gas. A piston is used to compress the gas. After the gas has been compressed, has the mass of the gas increased, decreased, or stay the same? Now, this is one that's a little bit different than liquids because this is a gas. So what happens is the mass is the same because you didn't put more stuff in or take more gas out. There's not more oxygen. You just squeezed the oxygen into a smaller space. So the mass is the same because you simply trapped it in a lower volume. So you may ask, well, what would be if the mass doesn't stay the same, then what is going to change? Well, in question number 6, the answer is going to be you now have the same mass in a small volume. Since we have the same mass of gas, in a smaller volume, the density has increased. Is it still oxygen? Yes, but now it's compressed oxygen. So you say, well, if the density of oxygen doesn't change, what happens? Well, we can compress it to a point and it still be oxygen. After we move, if we compress it too much, things start to happen that are a little weirder than that, and you might have chemical reactions with things. But in this case, we're taking the gas, the oxygen, and we're just forcing the particles closer together. They will do that for some amount of time, but at some point you're not going to be able to compress it any smaller. But our density that we would measure would now be a larger density because our gas is now under a higher pressure. That's how we would explain this. So this would be high pressure oxygen, not higher different something than oxygen. Okay? Number 7. How could we find the density of an irregularly shaped object? Well, there's lots of ways to do that, but one way we could do that is that we could measure its mass using a balance beam or digital balance, and then find its volume by putting it in water in a graduated cylinder and measuring how much volume change we got. Measuring how much the volume changed. Okay. Now, number 8. What does it really mean when we say the density of material is 2,000 kilograms per cubic meter? For every chunk of material you possess, the ratio of mass to volume for the chunk will equal 2,000 kilograms per meter cubed. So if you have 4,000 kilograms of mass, you must have 2,000 meters cubed of volume. We can go the other way as well. If I have 1,000 kilograms of mass, then I would only have half a cubic meter of volume. Okay, so the proportion will stay the same. For every 2,000 kilograms of the material I see, I will see 1 square meter of space being taken up. But that ratio can change depending on how big a chunk or how much material you start with or end with. How can we find the density of a liquid? That's a toughie, isn't it? The way you would find the density of a liquid, you're going to have to compare it with other liquids. other liquids to see if it sinks or floats in the known density fluid. An alternative way to do this, because there's another way to do this, is to use a graduated cylinder to find the volume and use a container on a scale to find the mass. Because in this case you can take the empty container's mass, so it'll be the total mass minus container's mass is equal to the object, the fluid's mass. And then of course you can just calculate it. Alright. The next two are going to have some various answers, so I'm going to just have to leave that as there are various ways to answer this. So on number 10, let's see, we got concept, questions, number 2. So various answers to this, but you must have a measure of the volume of the container and we must have a measure of the volume, of the mass of the fluid using what I said in number 9. So, for example, you could take a Ziploc bag fresh out of the package so that it doesn't have air inside of it or anything inside of it and find its mass. Then you could open it up, fill it with air, close it up, get the volume of it, because it usually says on the side like half gallon or gallon bag, and you can measure how much air you have inside, and then you'll know the volume of the container will give you the volume of the gas, and the mass of the fluid minus the mass of the total mass of fluid in container minus mass of Ziploc bag would tell you the amount of mass of just air. Okay, and so number 11 is going to be various answers, and it's going to play off the same ideas as above. So we're going to see number 9 and number 10 and see if we can state that as a way to actually do this. Okay, now number 12 had a typo. It should say 10 to the third. So there should have been a caret key in there. Will an ice cube float in a glass of alcohol? And the answer is no. The density of ice is about 970 kilograms per meter cubed, where the density of this material is 790, which is greater than the 790 kilograms per cubic meter of the fluid. So an ice cube would float. Most of the ice would actually be, well, not maybe most. A lot of the ice will be still outside the fluid, but it will float, it will sink. Density of ice is greater than fluid. So the ice cube would sink since it has a higher density. Sorry, I took a second on that. I was trying to fix the caret key so that they'll look right next time I give this. And then, of course, we've got what's your name at the bottom. I don't need to answer that for you because you can handle it. That's all for now. Catch you on the next one.